we finally come to the extreme edge of cosmological speculation, string cosmology. These models are based on an alternative to the standard quark model of elementary particle physics. So-called string theory, or M theory, conceives of the fundamental building blocks of matter to be not particles like quarks, but tiny vibrating strings of energy. Now, string theory is so complicated and embryonic in its development that all its equations have not yet even been stated, much less solved. But that has not deterred some cosmologists from trying to craft cosmological models based on concepts of string theory to try to avert the beginning predicted by the standard Big Bang cosmology. The most celebrated of these scenarios in the popular press has been the so-called Ekpyrotic scenario championed by Paul Steinhardt. In the most recent revision, the Cyclic Ekpyrotic model, we're asked to envision two three-dimensional membranes, or branes for short, existing in a five-dimensional hyperspace. One of these branes is our universe. These two branes are said to be in an eternal cycle in which they approach each other, collide, and then rebound again. And it is the collision of the other brain with our brain that causes our universe to expand. With each collision, the expansion is renewed. And thus these branes exist in an eternal cycle of approach and retreat, ever renewing the expansion of our universe. So even though our three-dimensional universe is expanding, it never had a beginning. Now, apart from its almost entirely speculative nature, the Ekpyrotic scenario is plagued with problems. For example, the Horava-Witten version of string theory on which the scenario is based predicts that the brane on which we live have a positive tension. But in the Ekpyrotic scenario, it has a negative tension in contradiction to the theory. Attempts to rectify this so far have not been successful. Second, the model requires an extraordinary amount of ad hoc fine-tuning. For example, the two branes have to be so perfectly aligned with one another that even at a distance of 10 to the 30th power greater than the space between them, they cannot deviate from parallel by more than 10 to the negative 60th power. There's no explanation at all for this extraordinary setup. Third, the collapsing and retreating branes are the equivalent of a four-dimensional universe which undergoes an eternal cycle of contractions and expansions. In this sense, the cyclic ekpyrotic model is just our old friend, the oscillating model, writ large in 5 dimensions. As such, it faces exactly the same problem as the original. There is no way for the universe to pass through a singularity at the end of each cycle to begin a new cycle, and no physics to cause a non-singular bounce. Finally, even if the branes could bounce back, there is no means of the physical information in one cycle being carried through to the next cycle, so that the ekpyrotic scenario has been unable to deliver on its promises to explain the large-scale structure of the observable universe. These are just some of the problems afflicting the model. It's no wonder that André Linde has recently complained that while the cyclic ekpyrotic scenario is very popular among journalists, it has remained rather unpopular among scientists. But let all that pass. Perhaps all these problems can somehow be solved. The more important point is that it turns out that, like the chaotic inflationary model, the cyclic ekpyrotic scenario cannot be eternal in the past. In September of 2001, Bord and Vilenkin, in cooperation with Alan Guth, were able to generalize their earlier results on inflationary models in such a way as to extend their conclusion to other models, Specifically, they note, our argument can be straightforwardly extended to cosmology in higher dimensions, specifically brain cosmology. According to Vilenkin, it follows from our theorem that the cyclic universe is past incomplete. That is to say, the need for an initial cosmological singularity has not been eliminated, and therefore such a universe cannot be past